Welcome to the world of Fmatic. Let me introduce myself. I am Julia, the sales manager at Fmatic Corporation. For those who may not already know us, we are a leading company in the production and marketing of automated solutions for entrances. With over 30 years of experience, we stand out for the quality and innovation of our products, all of which are strictly made in Italy. We have appropriate solutions for every requirement, and with these instructional videos, we will assist you in exploring all our products that have been developed and crafted to enhance the ease and safety of your life. In addition, we provide our clients with a totally costless service for technical and commercial assistance. Are you ready for an adventure in the world of Fmatic? Let's go. Good morning, everyone. Today we will talk about a very interesting topic, sliding gate automations. What are sliding gate automations? They are electromechanical devices designed to make your sliding gates automatic, allowing your gates to open and close automatically. On which gates can we install Fmatic automations? They can be installed on residential gates, so we're talking about condominiums or private homes, on industrial gates, so warehouses, companies and parking lots, or on gates of public facilities, such as hospitals and schools. How to choose which automation to install on your gate? First, you need to consider the weight of the gate. Then you need to evaluate the usage that the automation will have, whether it's intensive or semi-intensive. And then you will choose the type of power supply, whether it's 24V, 230V, or 380V. These factors are crucial in making an informed decision for your gate automation installation. Furthermore, we would like to remind you that it is of utmost importance to consult a professional in the field for both installation and expert advice on what to install. In this regard, today our technician Pierluigi will present to you the full range of our sliding gate automations.
I am Pierluigi, the tech from Fmatic. Today we'll present our sliding motor range. Of course, we divide our motors into two main categories, 230 and 24 volts. Let's start with the smallest one, our KV4. 230 volts voltage for residential use, maximum 400 kilograms. Moving on to the KV6, our flagship weighing 600 kilograms, operating at 230V or 24V with residential and condominium capacity determined by cycle count. KV8 always in dual versions 230 and 24, V800 130 24V. 800 kilograms capacity, our KV10 up to 1,000 kilograms in 230 or 380 oil immersed version, our K20 with a maximum of 2,000 kilograms in 230 and 380 volts oil immersed version, and then our industrial motor, the Giga 5000 with a maximum capacity of 5,000 kilograms in 230V with inverter, or 380V with contactor control panel. These motors have the ability to be offered on the market for all our solutions. Of course, we need to assess the weight of the gate and the workload they will have to carry out.
Once the suitable product for our use is chosen, we proceed to analyze a typical installation. During the typical installation process, we will have the following key points: motor body, flashing light, selector, photocells, and the rack system in place. There are two fundamental aspects to take into consideration in the installation process: the capacity of the motor and the safety of the system. The motor body will be attached to the ground using its fragile backplate. The flashing light will be installed high up on one of the two columns. Depending on the system, it is possible to mount either one or more pairs of photocells or a single pair of photocells. The rack can be classified into two primary categories, nylon and iron, depending on the weight of the gate and the choice made by the installer. The certification of the automatic gate is issued by the installer because this is how it works. We, as product sellers, provide certification on the product itself with the ISO 9001 standard, which complies with both the electronic and mechanical parts. The use of the product is, of course, certified by the installer, who must ensure the system's safety and compliance. If our automated system is not responding to commands or in case of a power outage, please refer to the manual unlocking mode in the provided instructions for assistance. In the majority of instances where the automation opens but does not close, it is because of the safety system of the photocells. Often the photocell is either dirty or faulty. In the case of random autonomous gate openings, it is necessary to check the start inputs or remote controls and then physically inspect if there are start points from selectors, buttons, intercoms, or if there is a possibility that some radio interference has occurred at the gate. It is recommended to reset the remote controls and reprogram them. The reasons could be twofold. Either the remote control battery is running low, or there are some interferences in the area that have reduced the reception capacity of the antenna and the receiver itself. For the solution, one can check either the battery or introduce an external antenna or an external receiver.
Now, let's see the contents of a standard KV10 kit.
This kit comprises mechanical and electronic assembly instructions, mechanically only starts, a fixing counterplate with attached bolts, and an engine body with a control unit inside. In terms of accessories, a flashing LED accessory with a mounting cover, a DF-matic 433 MHz remote control, a pair of adjustable photocells, and a monitor sign.
In the composition of the kit for sliding motors, the accessory for the rack must obviously also be installed, as it is essential for the proper operation. We have two types of racks, nylon with an iron core and one entirely made of iron with 8 weld lines. With motors up to 1,000 kilograms, we can install the nylon one, which ensures excellent quietness and much more practical operation in installation thanks to self-drilling screws and adjustment slots. In the iron rack, there are the studs that will initially be welded to the gate, and then the rack itself will be securely fixed using the fixing screws on the slot. Two minor suggestions for the mechanical installation of the engine. We will need to attach the base plate to the ground surface. In the base plate, there are pre-existing holes for cable passage, holes with bolts for securing the engine in the upper part, and holes for fastening the base plate to the ground. These holes have already been drilled and need to be securely fixed to the ground, aligning them with the floor using Fisher plugs or a threaded bar combined with chemical adhesive for maximum stability and durability. Once the base plate is secured, we will place the engine on top. Of course, there are openings that enable us to modify the engine's position for the ultimate fixation. After completing this step, we will move on to positioning the rack. When securing the rack, it is crucial to always maintain a small gap of a few millimeters between the gear and the tooth of the rack itself using the slots. This ensures that the gear is never overloaded with the weight of the gate and prevents any unnecessary strain on it. Let's take a look at our ECOS 230 M1 control unit. This is the control unit we will find on all sliding motors powered by 230 volts. To initiate the analysis, let's examine the connections starting from a low voltage terminal block. The first input pertains to the start function. The second input corresponds to the common connection, and the third input is designated for the pedestrian function. In the event that we need to connect a key selector, an intercom button, or a generic opening button, the connection will be established between the start and common terminals in a normally open configuration. The pedestrian input follows the same principle, with the common and pedestrian contacts always being normally open. Subsequently, terminals 4 to 7 are allocated for the connections of the safety devices, ensuring their proper functionality. Connection to photocells incurs costs for opening, with 5 photocell connections and 6 common contacts. There is also a stop contact at position 7. Each connection is normally closed. If the connection with the device is not used, It is recommended to leave the factory-installed bridge. In the case of a connection with the photocells, it should be placed between the common and photocell contacts. Only this jumper should be removed, while the others are left intact. Additionally, there is a part of the limit switch connection with a common contact at position 8, an opening limit switch at position 9, and a closing limit switch at position 10. It typically arrives pre-wired with the control unit on board, contact 11 and 12, as well as the 24-volt power supply for external devices. During the process of connecting the photocell, it is important to note that both photocells will be powered by the two terminals. The receiving photocell, which also has the contact, should be connected to terminal 5.6. Moving on to the 230-volt connection, we have terminals 13, 14, and 15. Terminals 13 and 14 should be accompanied by the capacitor or power capacitor on the two motor phases. As for terminal 15, it is dedicated solely to the motor common. Additionally, terminal 15 is used for the connection of the courtesy light and the flashing light. For the courtesy light, terminals 16 and 18 should be utilized, while terminals 17 and 18 are designated for the flashing light. Furthermore, we need to consider the connection of the 220 line for the central power supply, as well as the two terminals required for the earth cable connections. These terminals are responsible for connecting the earth coming from the motor and the earth coming from the line. If there are any other devices that require this connection, we will thoroughly analyze and address them accordingly. Now, let's proceed to examine the operating options of the control unit and its trimmers. It is worth noting that the control unit features two distinct trimmers, power and power slow. The reason for these trimmers being distinct will be elaborated upon. For a very simple reason, power will manage the force during the motor's regular operation, while power slow will manage the force during the motor's deceleration movement separately and distinctly the management of these two forces. In relation to the dip switches, it is apparent that they encompass a range of values starting from 1 and extending up to 10. Now, let us delve into a comprehensive analysis of their functionality. Dip switch 1 assumes control over the operation of the motor that drives either the sliding or swing gate. In the event that we activate dip switch 1 by setting it to the on position, it signifies our intention to utilize the swing gate configuration. The tilt setting simply means that when the control unit detects the closing limit switch, it does not immediately stop its movement, but instead allows it to continue for an additional 2 seconds. The dip switch number 2 is set to the on position for automatic closing. The control unit is aware of this setting and will automatically close the automation after a specified time determined by us, using its operating logic. Dip switch number 3 is used to select either the condominium function or the step-by-step function. When dip switch number 3 is in the off position, the control unit will perform an action such as opening, stopping, and closing with each start impulse. However, when dip switch number 3 is in the on position, the control unit will not be affected by any opening that occurs during this maneuver and will always complete the movement. If the dip switch is pressed while the automation is in the closing phase, the control unit will reverse the movement and reopen. Dip switch 4 is utilized to reverse the direction of the motor at the end of the stroke in the event of motor positioning to the left or right. Dip switch number 5 is utilized for the option of the coast or opening photocell. With dip 5 set to the off position, if the opening photocell or coast intervenes, the automation comes to a halt at that precise point. Alternatively, if it is set to the on position, it releases the obstacle, allowing it to come to a halt, reverse for a duration of 1.5 seconds or 2, and then come to a halt again, waiting for a new command. With dip 6, we manage the flashing light. The flashing light can be steady or intermittent. By setting dip 6 to the off position, it remains steady, whereas setting dip 6 to the on position allows the control unit to manage the flashing. During the opening, there will be a slow flash. During the pause time, a steady light. And during the closing, a rapid flash. Dip switch number 7 is responsible for managing the slowdown feature. When dip switch 7 is in the off position, there will be no slowdown. However, when it is in the on position, the slowdown will be activated during the run. Dip switch 8 is used to control the encoder, which is a magnet with 3 turns placed on the motor. If this magnet is not present and the device is not installed, dip switch 8 must be strictly left in the off position. Dip switch number 9 is dedicated to certain remote controls that have the capability to enable programming from the outside. On the other hand, dip switch number 10 is used to manage the mode of the motor's inertia, specifically for heavy gate or light gate mode. In order to proceed with the timing storage, it is necessary to perform the following steps. Close the gate, ensure that the LFC LED is off while the other LEDs are on, and press the prog time button for 2 seconds to enter programming mode. During programming, the gate will open with 1 impulse, then a second impulse will be used to indicate the desired slowdown point and activate the opening limit switch. Pause time will be counted during this process. When we have an ample amount of time, yet another impulse will be triggered to close down the automation, followed by another impulse to gradually slow down the automation, ultimately activating the closing limit switch. Programming has been completed. Now, with each of our commands, this cycle will be fully completed. Opening, limit switch slowdown, pause time in preset counting during programming, closing limit switch slowdown, automation in operation. Now we will briefly explain how our safety devices work. When the opening photocell, which is connection 4, 6 is activated, the control unit will immediately stop the movement. If we connect the photocell to contact 5, 6, the closing photocell, during the opening, nothing will happen and the gate will continue to open. However, if the automation is closing, it will stop, reverse the movement, recount the pause time, and attempt to close again. Of course, if the photocell has been cleared, we can declare the automation installation complete. Our safety devices play a crucial role in ensuring the smooth and secure operation of gates. By detecting the presence of objects or obstacles, such as vehicles or pedestrians, the photocells provide an additional layer of protection. The control unit processes the signals from the photocells and initiates appropriate actions, such as stopping or reversing the gate movement. This ensures that any potential hazards are effectively addressed and the gate operates in a safe and reliable manner. With our automation system, you can have peace of mind knowing that your gates are equipped with advanced safety features.